You were in the email, but you're. Do you know how long ago? You stole.
You know what the line is? Sat there and just
Let's return. Freaking
is it like soulbound to them? Oh, yeah, but sat on the table was the ring. Okay. Yeah. Anyway. So, Mr. Davis, what is CC Sox like? You can pick an animal. I was saying, yeah, a narwhal. That's the. It's a uniform. Yeah, that's my point. It needs a different nose. It needs something on the side. Yeah, she's embarrassed by her
Oh
socks.
yeah, I was gonna give one to Rachel to give to you, but she didn't seem to think you wanted it coming. So
Off class.
yeah. You guys could have done it like I did. It's been great. I'm gonna go through. So there's like 4 or 5 types of problems on there that I'm gonna go through. One of each one with you, or 2 if we need, and then the rest of it will be for your homework. So it's kind of combining the calculus, which finds the instantaneous slope, remember, with some algebra. So can you find the equation of the tangent line? Can you find the equation of the normal line? Can you find where the slope is horizontal? Things like that. So I think I put 4 questions in each section. And these concepts carry on for the whole year. So what happens is, here's how you've learned like a very basic, here's how you take a derivative, right? So we'll start applying these concepts. Now what do you do with it? And then the derivatives just get harder and harder and harder. But we still do the same things with it, if that makes sense. So trying to get like the usage of it, and then we'll ramp up the derivative level. So first part here, find the derivative and sketch the tangent line. So sketch the tangent line is, if you went to x equals 0, and this is a tough one. This is like really steep. If I went to x equals 0, you're sketching that instantaneous slope, or like we talked about, if you were like driving down an icy road and then right there you lost traction, you would just keep going in that same direction. Or the sun is orbiting around the Earth. This is actually how calculus was invented. Newton was trying to figure out like the rotation of the sun around the Earth, and he like stumbled upon like, oh, if gravity stopped. Did I say sun around the Earth? Twice? I think I said it twice. Earth around the sun.
That's how it works.
Earth around the sun.
Does it work like that?
Mr. Davis, the flatter.
I'll do, yeah.
The world is flat.
So he stumbled upon, well, what if the sun's gravitational pull just stopped? Well, the Earth would just like wander off in a straight line. And then he was like, okay, that's the instantaneous slope. Oh, this is calculus. Look what I just did. So,
I don't understand how you see the calculus. But
yeah, I mean, I'm not sure he named it, but.
I'm going to call this Isaac Newton's second invention.
So, sketching the tangent line. Again, it's tough on this one, but it should be something like this, where if you took the instantaneous slope at that point and extended it in both directions, you'd get a line like that. It is possible that your tangent line hits the graph in other spots. This one just doesn't. But see, people are sometimes afraid to do that. But for example, if I wanted the tangent line right there, that would have to hit the graph, wouldn't it? You know, you'd be something like this, and it hits the graph a bunch of times. So your tangent line can hit the graph. It just represents the instantaneous slope at that line, at that spot, extended in both directions. Yeah.
How do we know which way it's extending?
Both.
What do you mean?
So this is the x equals 0.
Yeah.
So I extended it that way and that way, and it makes a line.
But what if it's like left and right, not up and down? How would we know which way it is?
I'm not thinking about it like left or right or up and down. I'm thinking about it like if I gave you that point, let's say,
Yeah.
what would you estimate the slope is at that exact point?
X equals what, -1.5?
That's not a slope. You're just reading the graph. So, like, let me show you something. Hold on. This will help. Function surfing.
Oh, I get it.
Just like seeing the dude surfing helps, right?
No, it's not even that. I just get it.
Couldn't you have at least said, yeah, Mr. Davis, that was cool how you showed me the surfer and like made me feel good
Yes.
about myself?
Yes, Mr. Davis, that was
Like,
cool.
no, jackass, I have nothing to do with it. So, this is what we're trying to find. At any point, if I went to x equals -5, x equals -5 is down here. So that surfer is pretty much flat at that point. I think if I could draw it accurately, it's probably 0 right there. I just can't quite get it. If I went to if I went up here, right at this peak, what would your slope be? 0, and the surfboard will be flat, right? And then your surfboard starts going down. Then your surfboard flattens out. Your surfboard starts going up. What? It says function surfing, but if you want to think about it as a skateboard, go for
Because
it.
it kind of looks like the guy is on a skateboard.
How can you tell the difference between a surfboard and a skateboard?
There's there's wheels on both sides.
There's not wheels.
Oh, that's the A.
But yeah,
A right there made it look like there was a wheel.
but what is this little part?
That's the little thing that goes in.
The shark that's coming to kill you? So this is when it says draw the tangent line, this is what you're trying to draw. Does that help? Does that make sense?
Yeah.
Alright.
Thank you.
Yeah. I meant to show you guys that before, but just forgot. Alright, so all they're saying here is find the derivative of the function at the given point. So they gave us r. You're just trying to find r prime, and then plug in the x value. So this would be 3x squared minus 14x plus 11. And then to write this properly, you would say r prime of 0. R prime and then parentheses 0. And you're plugging in 0. You don't really have to write it because you can kind of tell it's just going to be 11. And then when you get your answer, think about, does it make sense? Does it make sense that the slope of the line that I drew is 11? Yeah. It's pretty steep. It's positive. I think that makes sense. Yes, sir.
So how do we know to plug in at R prime 0?
Because it says x equals 0. And it says,
Yeah, but how do we know to do the derivative before we?
because it says find the derivative of the function.
Yeah, but then does it say like then? Alright, never mind.
I think I'm supposed to say there are no stupid questions, but I'm going to have to agree with you on that. Try number 2. So do 2, and then 3 and 4 will be kind of your homework. And after you guys do 2, we check it, we'll move on to the next section. But this is what I'm trying to teach you too, Sheila. This is what we're doing.
Yeah, that was just a stupid question on my part.
I think some of you are done with 2 and moved on to 3 and 4, but I can't tell like if you're working on. Like, are we done with 2?
Yes.
You guys are still working, but I think you're probably going forward. Okay. So at t equals 3, that would be right at the peak of this, and your surfboard would be just horizontal, right? So we can kind of tell right now, what should I get when I take the derivative and plug in 3? What should I get? I should get 0. So if you get that, you should feel good. If you didn't, you probably did something wrong. So h prime of t would be negative 2t plus 6. H prime of 3 is then negative 2 times 3 plus 6, which is 0. And it makes sense. It fits our graph. So we're kind of checking it graphically and algebraically, and we get the same thing, and that's good. All right, turn the page, please. Stop working. Stop trying to get your homework done while I'm teaching. Bunch of animals. Read through the directions here. Isn't that the exact same instructions as number 1 through 4? Just phrased differently? It's the same exact problem. So find the slope and find the value of the derivative are the same. Because the slope is the value of the derivative, or the value of the derivative is the slope. So this is the exact same as numbers 1 through 4. So I'm going to sketch it. So x equals 0 is here. I believe that's horizontal there. Maybe not. Let's check. So g prime is 3x squared minus, yeah it is, minus 2x. Can you stop hiccuping, please? People are trying to learn. Unbelievable. Who was that? So if you take the derivative and plug in 0, you do in fact get 0, so this is a horizontal right there. Questions on 5? I'll give you a second to do 6 if you want to try that, and then I'll move on to the next type. It's like the exact same problem, basically. It's just upside down. Please make sure you're sketching, and there's no answers for that part because I kind of added it in. But I can show you up here if you want to look at any of them. So that one's horizontal also, right? We getting that algebraically and graphically? We good? All right, let's go to number 9. So it does get a little bit beyond, a little bit tougher here, a little more. Just adding in, so now we have that line, and I have found the slope of that line, but I can also find the equation of that line. So when you're finding the equation of the tangent line, when you're finding the equation of any line, I would start with this form. So y equals blank times x minus blank plus blank. And then what's going to go here is the instant slope. What goes here is your x value. What goes here is your y value. Sometimes they only give you the x value and they make you plug in to find the y value. If I had an x value and I wanted the y value, what would I do? Plug into which equation? The original or the derivative? The original. So the original will tell us y values. The derivative will tell us slope. But they give me both here. So I'm just going to put -1 there and 0 there. So I'm just going, okay, you gave me the point. Thank you. -1 1, 0 is right there. I hope these aren't all horizontal. So that's going to be horizontal. We can kind of tell by looking. So we should be able to get to that. So to find the instant slope, what do? Take the derivative and plug in. So my derivative would be 2x plus 2. I switched them from s's because my s's look like 5s. A common mistake I'll see is people will take this 2x plus 2 because like you know it's the slope, and you know slope goes here, and you'll write 2x plus 2 in this spot. But then if you like multiply it through, now you got x squared, now it's a parabola. That's not what you want. I want the numerical slope at that spot. So you still have to plug in the number. Here, what if I'll put that numerical instant slope? So I want the derivative at -1, so plug in -1. And that gets me 0. Question? Okay. But this does say I want the answer in slope-intercept form, so I'm not quite done yet. I'm pretty close on this one, though. So you just got to distribute through, but what's 0 times all that crap in there? 0, so that doesn't matter. So what am I left with?
0.
Well, y equals 0, right? Yeah. And so that's the equation of this surfboard, which we kind of could have told. We kind of knew that already, you know?
So I've got a question for you. This is kind of a deep thinker. It's not as stupid as the last one.
I'll be the judge
Is
of that.
0 positive or negative?
Neither. Do the next problem, please.
How?
How do you do number 10?
No, how do you have, how is 0 neither?
There, yeah, positive or negative is like distance from 0 on the number line, and it is not any distance from 0 on the number line, so it's nothing.
But it's 0 distance from there. So it's the equilibrium is what I'm hearing.
That works.
Thanks.
Try to think about why you're doing what you're doing. It's really easy to just look at the previous problem and like repeat those steps, right? But try to sink it into your brain that you're finding the tangent line. Here's the process to find a tangent line. You'll be finding tangent lines all year long. This is like one of the main things. So I think some of you guys are moving on again, but I'll do number 10. So 2, 1 is there, your tangent line, your surfer guide. Be something like that. So I got y equals blank times x minus blank plus blank. X value is 2, y value is 1. I want the slope to go in that spot, so y prime is -3r squared plus 8r. And then the derivative at 2 would be -3 times 2 squared plus 8 times 2. So -12 plus 16 is 4. So just like make sure that makes sense to you. Does the slope of 4 seem reasonable for that line? Yeah, it's fairly steep. It's positive, so you know that it's not a perfect check. But if you got like -2, something's wrong. You know. So put 4 here. And then do want your answer in slope-intercept form, so this would be 4x minus 7, because you'd have 4 times -2 is -8, plus the 1.
Oh.
How many had 4x minus 7 there? Questions? Alright, let's go to the next section. So now they're asking for the equation of the line normal. Do you guys know what normal means? Not like usual. But it matters. Normal means perpendicular. So if I have a slope, let's say the slope of my line is 3/4. Do you guys know the slope of the line perpendicular to that? Negative 4/3. You flip it over and you change the sign. So you flip and change. So if my slope was 4, what's perpendicular to that? Negative 1/4. If my slope is negative 2/3, what's perpendicular to that? 3/2. If my slope is undefined, what's perpendicular to that? 0. Good, because that'd be 0 on the bottom, right? If it's undefined, if you flip it, it goes on top. If my slope is 0, what's perpendicular? Undefined. So if the slope is 0, you're horizontal, right? What's perpendicular to that is vertical. And what's the slope of vertical? Undefined. So that's how it goes, like back and forth. So it's the same idea. You're looking for the equation of a line, so I'm going to start with this setup. But now what goes here is the negative reciprocal of the instant slope. And then when you're drawing it, remember you're drawing the perpendicular. So 2 comma negative 6 is down here. So if I were to graph the tangent line, it would be something like this. But I'm not graphing that. I'm graphing the line perpendicular to that. So you want to make a right angle with that tangent line. So your normal line should be something like this. When you're thinking about checking your answers, the slope that you get to plug in here, should it be positive or negative? It should be negative, because our normal line is negative. So if you are putting in a positive number, just kind of stop and check yourself. Wait, it's supposed to be a negative slope. So h prime is negative 4x plus 16. H prime of 2 is 8. So 8 is the slope of what? That's the tangent line. What's the slope of the normal line then?
Negative 1/8.
Negative 1/8. And then they want it in slope-intercept form, so we got some annoying little fractions to do here. I'm going to let you guys have fun with that. It would be negative 1/8 x plus minus 11/2, I think. Is that right? No, not right. That'll be 5 3/4, so 23/4. Did you say close? Trying to encourage me. Thank you. Yeah, I had 5.5. It was 5 3/4. Does that process? I don't really. I'm not worried about the decimal fraction part, but does the process make sense? Do the next one. We're cruising right along. We're done with calculus in no time.
Do we ever finish what do we do at the AP test in here?
Number 14, please. Yeah.
We do 14.
This one's a little different. You do get something kind of goofy, and you should. Were you at the event thing or no? Alright, so this one does come out a little weird. And you can tell by looking at the graph, but you won't always have the graph. So it's designed to like help you understand what's happening. But it does make your job a little easier, and that will go away eventually, the graph part. So the tangent line would be horizontal, wouldn't it, your surfboard? So your normal line is perpendicular to that, which would be vertical. So keep that in mind when we're doing it. So the derivative is 3w squared minus 2w. So the derivative at 0 is 0. So the tangent line of the slope is 0, which is what kind of line? Don't say straight.
Undefined.
That's not a kind of line either. What is the slope of 0? What kind of line is the slope of 0? Horizontal. You're going to love this one over me. Got zeros. Right in the word. Look, Josh. Look at it. Stare at it. But for this problem, I want the normal line. So if the tangent line is horizontal, what is the slope of the normal line? Undefined. So this doesn't really work anymore. This little setup that I gave you fails in that one scenario. We know the tangent line is supposed to be or the normal line is supposed to be vertical. What is the equation of any vertical line? X equals a number, and in this case, the number is 0, right? Here, another one. X equals is a vertical line. I'm just trying to make Josh as mad as I possibly can. Vertical, exactly. How many had that? That was a little tougher because you get that horizontal vertical thing in there. Does that make sense when I go through it? Yeah.
Do you only need to? Will that only be the case? Never mind. That's a stupid question.
He's self-censoring now. All right, one more section.
Second of the day. Usually not one. Or class, obviously.
Tangent line is horizontal. So what that means is I want the instant slope to be what? I want the tangent line to be horizontal. What do I want the instant slope to be? Vertical isn't a slope. 0. So if I want the instant slope to be 0, well, how do I find the instant slope? I take the derivative. So this is a super common question that goes throughout the whole year. Tangent line horizontal means you want the derivative which represents the slope, remember. You want it to equal 0. So I have a graph. I can kind of tell the answer. What x value on this graph would give me a horizontal tangent line? It's right there, so it should be at x equals 1. I can see that. That's where the surfer would be flat. But finding it algebraically, I'm going to take the derivative. This derivative represents what? What does the derivative always represent? The instantaneous slope. And if I want it to be horizontal, what do I want the instantaneous slope to be? Set it equal to 0. And then if I solve that, 2t equals t and t equals 1. So that's right there. I'm not done with this. People screw this up a lot. You turn that in like this, and I mark half off, and then you get mad. What am I missing if you read through the directions? The y value. It says points. It doesn't say find the x value. Sometimes it will say find the x value, and then you could just stop. But this says find the points. So now it's like 1 comma what? And you do have a graph. But if you didn't, how would you find the y value? Plug back into the original level or the derivative level? Original level. So if I plug in 1 in the original, I get -2, which I can tell by looking at the graph, but I can also do it algebraically. Questions on 17 to 18. this is what we talked about a few times today. We'll keep kind of adding to what these things tell you, but the original tells you y values. It also tells you horizontal asymptotes and vertical asymptotes. We've done that. And then the derivative tells you the instantaneous slope. Again, try not to just, I'm doing this because I did this in the previous problem. Think through why you're doing it. What is asking me to find? Okay, that means I do this process. That's going to get in your head way better than if you're just repeating, like mindlessly doing number 17 again. Okay, why am I doing it? What am I trying to find? What does this mean? That's how it gets into your brain. Probably do a worksheet very, very similar to this tomorrow. This is, I don't think it's necessarily that difficult, but it's really important. It's like a foundation to the whole next month. 2 months, 6 months, really. Am I good to go through 18?
No.
Like I can't tell how far you got. Okay. So again, I want to think through the process. I want the tangent line to be horizontal. So I want the instant slope to be 0. Well, how do I find the instant slope? I take the derivative. So t prime, I'm going to use x's, would be 3x squared minus 2x. They do not do a lot of variety here, do they? I want that to be equal to 0. So I'm going to solve that. Some of you guys might not have solved this correctly. I'm not sure. What would you do to solve this? True or false, I would add 2x to both sides. False. If you do that, you're going to end up canceling out an x and you'll lose one of your answers. So factor. So I can take an x out of both of those. And then solve both those pieces. So that just gives you x equals 0. And this piece gives you x equals 2/3. And again, I'm not done. It'd be tempting to stop there. The directions say find the points, not just find the x value. So this one is 0, comma, and again, what do I plug back into to find the y value? The original level. So 0, comma 2, that one's easy. 2/3 is kind of annoying, but that's alright. So I'm going to have 2/3 to the third minus 2/3 squared. Plus 2. Is the first one minus? Yeah, okay. So 2 cubed is 8. 3 cubed is 27. 2 squared is 4. 3 squared is 9. Plus 2. I'm going to need a common denominator. I'm going to use 27. So this would be 12 27s, and this would be 54 27s. Because like this would reduce down. I multiply the bottom by 3, so I multiply the top by 3. Here, I multiply the bottom by 27, so I multiply the top by 27. And then 8 minus 12 is negative 4. Negative 4 plus 54 is 50. So this will be 50 over 27. For my other point. Now I can crap all the way. Here's my answer, here's the work. Questions on that one? And this is where this is the difficult part. So once you remember the process and get used to it, it's not the calculus. Like the calculus there was not hard. This was the calculus. That's it. And then it was algebra, advanced algebra, fractions, remembering the process, you know. Questions I can answer? So your job is to finish everything in that packet for tomorrow. And we just did, probably half of it. Basically half of it. I want you to have everything else done for tomorrow. We'll probably just keep doing this again tomorrow with maybe a little more difficult derivatives, but the same concepts.